Two of the most important concepts that are used throughout calculus are tangent lines and rates of change, which lead to one of the most used calculus things, derivatives. Tangent lines to graphs are useful in many applications of calculus. In geometry, the tangent line L at point P on a circle may be interpreted as the line that intersects the circle at only P, this point here. But in calculus, we extend our knowledge to know that the point at which it touches is also the slope of the circle at that point. For example, if the tangent line was here, the slope would not exist. If the tangent line was here, the slope would be 0. To find the slope m of the tangent line to the graph of a function f at any point p, we use the equation m equals the limit as h approaches 0 of f of a plus h minus f of a over h. For example, to find the slope of a line tangent to the graph y equals x squared at any point p where the coordinates were a, a squared, we first plug in a to the equation. For example, m is x plus h squared minus a squared over h. We then factor this out and we find that these two terms cancel. And then we are left with this, which then you can factor in h out of, and you end up that the slope is 2a. So at any point a, plug in a number. For example, at the point -2, we can plug this in to find that the slope is -4. We can use something called the instantaneous rate of change to find slopes of a graph at any given point. This gives us information about the rate at which the graph rises or falls per unit change in x. Here, the red lines are used to show the slope of the blue graph at any given point. For example, at A, the slope would look something like this. At B, it would be a bit steeper. C, it becomes negative, and D, even more so.